welcome to this episode number 6 of the series Tuesday Night Live, which normally we talk about our game jam, and also we talk about programming. We are going to continue with our series on programming the VIC2 based on the articles that or notes or whatever that Emanuele did. May I remind you also that Emanuele is not English native speaking, so his English
Absolutely.
his English can be, let's say, not up as we are used to. So please give him a chance, and if he is not clear, I will always repeat after him and explain things. As we start with the usual stuff, first of all, hello, Emanuele.
Hello to all
Finally,
our followers.
Finally we are online after all the crap that we had in the beginning. I hope that it didn't discourage you to continue to follow. So, as you know, we have our game jam, which, as you can see on the screen, we only have 1 month, 15 days remaining, so 1 month and a half, which me personally, I am very, very behind. It is about making a game for our 8-bit and 16-bit machines that we love, our retro machines. And please, if you think you can participate, if you think you can, then just start, because you only have 1 month and 15 days, 1 month and a half. As you know, I am by the sea, so you can hear the seagulls. I think they are. You can hear them. I'm not sure, but they are very loud today. Our lovely seagulls that wake me up in the morning. So, besides our game jam, may I remind you to like our videos on the Phaze101 YouTube channel, and also like the videos on Retro Programmers Inside. And funny enough, I'm seeing myself there. Also remember that under each video, there are comments where you can find links to source code, etc. And there are also the chapters. Like in this case, you can see the chapters in relation to this video, but also you can also see links to the playlist, to the source, and anything else related to this same video. I remind you also that there is the Phaze101 Facebook page, if you want to follow us there and like it. There is the Phaze101 Facebook group, and as some people know me that I like Commodore, I also have Commodore Dev. So all these groups belong to Phaze101, but then there is, I should have it, should be here, the Retro Programmers Inside, of course, Facebook group. So please subscribe. This is the best way, in a way, to get access to the game jams that Retro Programmers Inside organizes. Okay? If you like what we do, you can subscribe to support us on our where is it? Finished. There it is. This on our on Patreon, where you have access to more videos or streams related to programming, whether it is Commodore 64 or Amiga. I also have the Phaze101 Facebook Telegram group if you want to join and have access directly to me. But what I encourage is, and I'm going to, for those that do not have Facebook, please join the Discord channel for Phaze101, and you can see all the things related to the game jam in my Discord. Everything related to it, even I should have posted screens of previous games, not previous games, sorry, of what people are doing in relation to the current game jam. But also yesterday I was following Old School Coder, where he did he's continuing with the game, and actually I'm going to show it, why not, where you can see Nico, okay, trying to avoid nature. Let's put it this way. He ran away from Old School Coder because Nico is naughty. Anyway, he's not online now, Old School Coder. I don't think he is here, no? No. Also, I'd like to say hello to Derek Morris, the author of the 2 books. I just saw him in the list of people following. The author of the 2 books, Retro Game Dev, which a few days ago I couldn't remember the full name of it, but I have both books. I've read both books, and I recommend you to, get these books if you are interested in programming the Commodore 64, which, as you know, I also like. Not just the Amiga. Okay, so let's continue. So let me jump to the screen and to Visual Code. I'm going to remind you what we were doing because we took a break of 3 weeks or 2 weeks. I can't remember, 2 weeks, I think, because I was away. I was on holiday, and we are going to continue with programming the VIC. We were doing raster stabilization, and I'm just going to show you where we left. So let's run it. And as you can see on our screen, we have this stable raster, and we explain how to have a stable raster. This is our loop, just pretending to have something else going on, okay, while we are having the stable raster, just by updating the, let's say, the first character on the screen. And today we will continue with this. So we are going to switch to, so that was article 4 number 1. We are going to do article 4 number 2, okay, and I'm going to show you what we will do in what Emanuele will explain in this one. So before, the line was stable. Now you can see we have a stable raster line, but we can also move it. And the reason why he's using the border is intentional, okay? Just to show that we are using raster lines, not something else. Okay, so I will need to live share Emanuele. And I need to share the password with Emanuele, not the password, the link. Emanuele, you have the link.
Yes, I'm here. A moment. Boom.
Okay, accept read write, and I give you control.
Okay. A
You should have
moment.
control of my screen.
Trust. Perfect.
Yeah.
Okay.
Remember, Emanuele, to read your own notes, because you have a habit of not reading your own notes.
Yes. um, the first part of this program is the same of the same of the last program of the stabilization, raster stabilization. In this example, I have added the movement of the stabilized raster line. To achieve this goal, I stabilized first the raster line, and I moved it every frame in a direction, and when when the line have reached some points, I changed this direction. Okay. Here we have the constants. These are the normally constant that I defined in every example.
Yeah.
But
Yeah. So
in the
basically, Emanuele, sorry, I just jumped in, but just to
okay.
clear it up. So basically, now we are building on what we did 2 weeks or 3 weeks ago. So it's the same code that we had last week, but this time we are going to move the line. So the constants are the same, but he added, I think, one more line, which is the RST_wide, no? I guess.
Yes.
And he will continue from there. So, yeah, Emanuele, all yours again.
Okay. First of all, I added a constant that I used to have the range of the for last line position. In this case is 34, because I want to move the raster line in the very first part of in the very first upper part of the screen, on the border, upper border. Here is the entry of the same code of the other program, the program of 2 weeks ago. Here I initialize the ERQ. Is the same code that we saw the last time. Identical code. So after the initialization of the ERQ, the interrupt, we can find the infinite loop that pretend to make something like, in this case, increment the upper left corner of the background in the screen. The effect is the character that change every frame that you saw some minutes ago. Okay. Here we have the stable raster line -2 to stabilize the raster line. If you remember, we should choose a raster line. If we want stabilize the raster in a specific moment, we have to start 2 lines before. In this case, I want to stabilize the raster in the 16th lines, and so my interrupt service routine will start at the 14th raster line. Here I have a counter that I initialize with the raster wide constant, that is the range of the movement that the line will use. The direction is another byte that I use to choose what is the used direction. The direction can be 1 for down and -1 for up. -1 are in X is FF. Okay. Here, after this definition, this memory definition, I have the normal routine to start the stabilization. Here we save the register on the stack, like in the other program. Here we make we use the double interrupt technique to reach the stabilization exactly here. When we had reached the stabilization in a frame, I made some. I added some opcodes to lose some cycle, and to start changing color of the border at a specific place. We want to make a simple stable line appear 10 characters long, equal to 10 cycles, starting with the column of the first character of the left on the left of the screen, corresponding to cycle 14 of the raster line. If you remember the running part that James started before, our line starts exactly with the first charts on the background. On the background. Okay. So after this, after losing 14 cycle, sorry, 14 cycle are losing with 4, 7, and other 6 cycle. Sorry, 3, 5, 8 più 6, 14. No, sorry. Here we are in the in cycle 3 for 5, 6, 7, 8 plus 6, 14. Okay. Here I change the color of the border, but the color will start to change when this NOP operation starts. Every NOP is 2 cycle, so 2 characters, other 2 characters, and other 6 character. So total of 10 cycles or 10 chars. So here we have a line along 10 chars stabilized. Here we have our acknowledge of the interrupt like in the other programs. Now we decrementing the counter. The hour counter to sorry, per trovare il punto in cui cambiare direzione.
To find the point when or when to change
change direction.
To change direction, exactly.
Okay. When this if this counter is greater or equal to 0, we can be continue with our interrupt service routine. Okay, loading the raster, our raster line position for this time, and adding the direction. Okay, here this one is the byte that contain the line where the raster line where my line should be displayed. So so I take this byte and I adding to it the direction that can be 1 or -1. So if for example direction is 1, the line in the next frame will be down of 1 line, and I store the result in the same byte of that contain the actual raster line or the next raster line for the next frame. The position of the raster line for the next frame.
Okay.
Okay, and I explain another thing, and I ask you to explain better. Okay, if our counter is equal is a minus of 0, substantially -1. I use the two complement I use the two complement operation to change the direction. In fact, if direction is 1, with the two complements at the end, direction will be -1. If direction is -1, at the end I will have direction equal to 1. Two complements is a very simple operation. I take my this operation transform a binary number from its value to its value with the sign minus, with multiplicated for -1, changing the sign substantially. The operation is simple. First, I decrement my value direction. So I take the direction in the accumulator, and I make this operation, the exclusive OR, with the value, the immediate value of ffx. This invert all accumulator bits. If accumulator equal to 0, it becomes -1. So when the accumulator is 0, the direction before was 1. So direction 1, I decremented it, direction is equal to 0, with the exclusive OR ffx, the accumulator became -1. And so we have reached our goal. And I store the accumulator to the new direction. When the direction is -1, if I make another -1, if direction -1, the direction become -2, FEX. And with the exclusive OR, this became 1. And I reached I changed the direction again. Substantially, when the counter, that is that count the number of lines, or the number of frames where the lines appear, when the counter becomes 0, the direction change, and the counter is restored to its original value, the max value. Okay, can you explain better than me, please?
Yes. So, first of all, I am going to remind you what we did last time, because of course Emanuele skipped that part because we do not need to repeat what we did, but I'm just going to say the sequence. Remember, we initialized the raster line. So if we want to wait on raster line, let's say 14, or let's say 16, we initialized on raster line our routine on raster line 14, and then we do our calculations, which Emanuele explained last week, 2 weeks ago, of how to make sure that everything, is in line and in sync, so that we get this stable raster line. Then we call an interrupt, and within that interrupt we call another interrupt to be able to stabilize that. Okay, so that's how he was achieving it, and like that we obtained one line. Now what he's doing with that one line, it is he's changing the position where that line is. Okay, and basically has a loop that increments the line. When it reaches line, I forgot what raster line it was, line 30, I think raster line 30, right? Because Emanuele, what was the raster, the bottom of the raster line? Which line it is?
50.
50. So when it
50.
reaches raster
Because
line
the first line is 16
16
plus 34,
yes.
50.
So yeah, okay. So we start at line 16, so minus 2, which is 14, and then we go to raster line 50. Once he reaches raster line 50, so first he is adding, increasing the raster line where we do the check, and then he is going to decrement, and like that we obtain the effect of going up and down. He has a flag which is the direction. Okay, so if it's a 1 we are making, if it's a 1 we are adding, if it's at -1 we are subtracting, and we go upwards. Basically 1 we go downwards. Emanuele, I'm not sure if I ran with your code and I explained it already, but yeah, you can continue.
Okay. After that, we simply setting the back original ERQ vector, that is the vector for the pre-my ERQ. In fact, for the next frame we have to restabilize the line, but we should stabilize it a line after or a line before, according to this value. So the first stabilization is made to the 16 line. The second stabilization, that is the second frame, is made to the 17 line, and so on, until the counter became 0, or is equivalent. This byte point to the 15 line, that is the last line of the upper left border. When we reach this line, we change the direction, like we explained here. We trying to explain it here. I trying to explain here. And sorry, changing direction, we move the value of this byte from 50 to 49 to 48 and so on until 16. 16 is the very first borderline, upper borderline, is the first visible line of on the Commodore 64, substantially.
Sorry, say it again.
Okay.
Emanuele, say the last word. Did you need help?
Okay. I ended the explanation.
Okay. So you want me to explain? You want me to explain?
Yes.
Okay. So, did you do the whole? Did you do the whole source, Manuel?
Sorry.
Did you do the whole source? Because I do not want to.
Yes,
Did you?
I do the whole source.
Okay. So basically, you can see that we still have. I need to take control now. Okay. So
You have the control.
yeah. So this is how much our raster line is going to travel. So 34 lines down and 34 lines up. We still have the usual stuff, that is disabling the interrupts and setting up our IRQ. Okay. Once we set up our IRQ, which is this one, pre-my IRQ, this IRQ will call another IRQ. Okay, so this is for stabilization, and then the other IRQ, is it this one? Check. So pre-my IRQ, and you see without these I get lost, and because this week I didn't manage to do my own comments, because for me these are the barriers. So where is the second one?
No,
IRQ stabilizer, no? That's the one.
allora, prima IRQ is the first the first
This is yeah, Emanuele.
IRQ called.
This is the routine that you added, basically, right? That's the only part that you added.
Yes. The most important part of
Yes.
of this program is substantially
This part. It's this
the
part
changing of
the
the line
direction.
where I stabilize
Yes.
the
Yes.
IRQ.
So yeah, that's what I'm verifying. So all the code previous to where I highlighted is the same as the previous example. This is why I was asking the question, except for the fact that now we have this constant here. Where was it? At the top. Okay, so he added that constant, but the rest of the code is the same, except the last bit. Okay, this part. So here, okay, he is decrementing the counter, so I assume he starts from the bottom, right? And he's moving the raster line up in this part, right? And here, sorry, not this part. I forgot to mark it properly. I didn't mark it properly. This part. Sorry. Because here we set the IRQ back to what it was. So this part here is still the same code that we had in the previous, in 401, the first one that we did. So basically, we have a counter. He is incrementing it and decrementing it, and based on the value of the direction. So if the direction is 1, we are going down. If the direction is -1, we are going up. That's basically what you are doing. No, I mean it's only this part. We have a counter, so you are counting 34, and then you change the direction of what to add, whether you add -1 or 1, basically. So the counter is 34, we decrement, we add what we have in the direction, and then we set the IRQ to normal as it was. So not really much change from the previous example except this part. I'm just verifying that I'm not
Yes, is the last part the most important.
yeah, this part, no? I mean, this one is the most important, but this is what changed from
Okay.
the previous code.
And the bottom and the last two line before the restoring of registers.
This you mean? Here you mean? No, Emanuele, this did not change, no?
So sorry, I
These
can't understand you.
did not change.
Oh, I'm not changing nothing.
Yeah, you didn't change anything. You only changed this part. I mean, actually, not
Yes.
change. You edit.
Yes.
Yeah.
But
So,
that part is the most important part.
yes, that's all you did. So basically, so like that, we have a line that goes up and down. So from all the code, the rest of the code was already explained in the previous example, and we just have that. I mean, I can read what he wrote here. Okay, so he decrement the counter. If the counter is greater than 0, okay, we continue. So we decrement the direction, okay, we load the direction, we XOR it with FF. So basically he's changing from 1 to -1 when he XORs, and then he does the calculation of where the raster line is going. I think it's simple enough to understand it. To understand this, it's not the end of the world. It's more what was difficult, I think, was more lesson 1, where we explained the interrupts, and then from the interrupt we called another interrupt. Yeah. So we can jump to the next example, Emanuele.
Yes.
Yeah.
We can jump.
Okay. So before I do that, I'm just going to show something. Screen. Okay. For those that do not know, Derek Morris books are these. Okay. So this is the website. I can share the website. These are the books of Derek Morris. I hope he doesn't mind that I'm sharing them. I'm not sure if he's still here or not. No. So if you haven't got them, I encourage you to get them. They are two good books to read and learn how to program the Commodore 64 using assembly. So let's continue with our code. Let's jump to number 3, and I need to give you control. Now the code is going to be the same, okay? This is the same code that we had before. Okay, here's some more constants, okay, but the code is going to be the same. So this part is still the same. What he's going to change is down here, I believe. Yeah.
Yes.
Yeah, and probably he has a routine. So I haven't seen the code, okay? So this is the code that we saw before of change of direction, okay? So it's still the same, but now, sorry, from here. This is the same code that we saw in the previous example in 402, okay? But now he has a lot more raster lines to add, and I'm going to show you what I mean by that by running it. So now there are more raster lines. I don't know if it's 2 or 3. I think it's 2 there, right? And he's also changing the color.
Yes, it's a very simple example.
Yeah. The rest of the code is so for moving the bar up and down, okay? It's still the same code that we did in the previous example. You just have a wider bar, which is 63 cycles, okay? Because that's the width of the screen and it takes 63 cycles. And he's also changing the color. Anyway, I will let it up to him to explain. I believe it is somewhere here that he changed. Okay, so Emanuele, it's all yours.
Okay, but I continue to see the host has ended the current collaboration open folders and edit
Oh
will now
yes,
close.
yeah. You lost connection to the
Yes.
Oh, okay. Let's do it again.
Okay.
I can't understand why live share drops.
I don't know. I can't explain to you.
Yeah, full control again.
Now I see all tabs.
Ah, I don't know. Oh, so maybe it was still
I don't know
updating.
why.
Uh,
I don't know why.
okay. So all yours now again.
Okay. Okay. In the previous example, we have see only one little bar that goes up and down. Now our goal, how you saw some seconds ago, is to uh, um, made this the rust line thicker and colored. Um, allora, we have some constant, some new constant, RST goal, raster line where we make stabilization is the same like before. In order to stabilize the ERQ at raster line 30, we need to start the stabilization procedure to cycle before. That is the line 28. And I registered this on another constant, RST myRQ, the actual raster line used to beginning of all. That is 28 substantially. Is the first line where I should stabilize the raster line. Now we have the VIC register constant. We have the wide of the wide used for to count the frame to move our bar, and we have a color black constant that we used after. Okay, this is the same raster stabilization that we used before. No, the same raster initialization that we used before. We start the stabilization triggering the 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 the, the interrupt at this value, at this byte that sorry, that I defined here. Okay. That will contain the position where the line starts for every frame. These are the same lines of code to setting the control register 1 to achieve our goal. This is the ARQ activation mask, the enabling interrupt, our main loop, okay, that increment like before the first character on the screen. So we are the byte that contain the bar position for every frame, the counter initialized with the maximum value, the direction, like before, the direction could be 1 or -1, and now I added a byte to store the color for every change of direction. I want to change the color every change of direction, if you remember the example. Now we have our pre-stabilization routine that save the register. We have the double interrupt technique to stabilize the line.
Can you highlight when you are talking? Can you highlight to what we are referring?
Sorry. Okay. I start again. This is the part that saves the register on the stack, because before any interrupt service routine, we should save the registers, and restoring it and restore it after after the interrupt service routine is ended. Here we have our double interrupt. Sorry. We have our
We're going to swear in Italian.
double interrupt stabilization technique that we used, and now here we have stabilized the raster line at our predetermined line that is stored in our in our variable that I saw before, but now I saw again in a moment. The difference from this program and the program that I saw before, that I explained before, is that my raster bar starts with a change of color using the raw color label that I defined before. So I change the border color and the raster line in this case. Here I I used a long series of NOP operation instead of a loop, because substantially I'm a lazy boy. So I used various NOP to reach the lane of my of the raster line of the lane desired for my raster line. When I uh, when I reached my first part of the raster line, the line of my first raster line, I come back to the black color. Here I used the the constant that we saw before, because my the effect is for using many raster line, one next each other, um, to pretend to be thicker, raster line thicker. When I
Can
resetting
I stop you? Can I stop you
the
a second? So till line 346, okay?
346
Yeah, okay.
here.
Till line 346, you have 15 cycles, right?
Sorry. Okay.
Right?
I'm on the 15th cycle
Cycles, yes,
here.
1-5. Yeah, and then you are adding, if you how many you have there? Knobs. So
1, 2,
15, I
3,
think.
4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17.
Okay, so then you're
7,
adding 34,
34.
yeah,
Yes.
plus 15.
Yes.
And
34 plus
I'm
15.
just trying to understand where the 65 cycles are. So that's why I'm asking you. So
No, here,
when do you reach cycle 65?
I don't care of it in
Why
this case.
why you don't care?
The
You care.
65 is reached here,
Yeah.
but I'm treating it like um, I continue my I continue my raster
Yes.
service routine
Yes.
for the all four line without interrupting it.
Yes. Yes. Okay. Of course,
Okay.
because you have a
Okay.
stable line, so you are able to do that.
Eh, Exactly.
Yeah. But I'm trying. But you have.
I know where is
Yes.
where it is.
Yeah. But you have four four raster lines. You are waiting for one, but you are drawing four raster lines.
Yes.
Yeah, and each raster line is 65 cycles.
Exactly. 64.
Why 64, not 65?
Um, the 65 is the first cycle of the next one. If I here, I'm on the right edge.
Uh-huh.
Okay. Allora, let me account. Let me
I don't
some.
want to confuse you, okay? I'm just trying to understand how you
Don't
manage
worry.
to.
I confuse myself uh, uh, anyway. plus 17 for 2 is 49. 49, 51, 56, 59, 71, 72, 3, 4, 5. No.
No, I think what you did is you have 63 cycles, and then you move to the left
To the
edge.
next one.
Yeah, you move to the left edge. So from right you move to left, and then you do another 63 cycles.
Yes, this is my. I'm checking the not the code. The code is right. I'm checking the my notes.
No, I think your notes are correct. It's just that you are saying 65 there, so so it should be 63. Why it is 65, not 63? Because I think then you jump, no, from the right edge. So till the right edge you are 63. Then you jump to the next line, I assume, because then look, you are going to set the color again.
Yes.
If I'm confused, you ignore me. I'm just trying to.
No, don't worry.
Oh,
Hello,
Duncan. Ciao, Duncan. Anyway, Emanuele, please continue. I don't want to
okay.
confuse you or interrupt you.
I use the time to see on my Bible for
Uh-huh.
the VIC2
Uh-huh.
by Christian Bauer.
Uh-huh.
Okay. In the Christian Bauer Bible.
Can you share the link of it to it?
Okay. Yes, I never thought this. Okay, the link is this. This is the Bible for me, for the, I write here.
I can copy it in the.
Okay, I have simply extract a piece where he is explaining the various cycle on how the VIC reads the memory.
Mm-hmm.
Like you can read, the line starts with the cycle 1 and consists of 63 cycles on the 65, 69. This is the, come si dice sigla?
This is the signature.
The signature of the the VIC, depending on the period that it was built. Okay, and 64 cycle on this one, and 65 on this one.
Uh-huh.
This change by type of
Of the
if
VIC chip. So basically what Emanuele is
PAL,
saying.
PAL, NTSC,
Yeah,
and
let me explain it. Okay. So
okay,
what he's
thank you.
saying is that on this chip, no, we have 63 cycles. On this one, we have 64 cycles, and on this one, we have 65 cycles. Right? Did I say it right? L'ho detto
right.
corretto, sì o no? Emanuele?
Sorry,
L'ho detto corretto, sì o
ah,
no?
sì, sì, hai detto corretto.
Okay, he said that I said it correct. No, because I needed to verify.
Ok.
Remember, you can
No,
still talk Italian, you know, and I explain later. So instead of
mm,
fighting with yourself, talk Italian.
ok. Uh, so we are here. When we reach the border, the right edge border, substantially we have changed the raster line, and I used some other knobs to reach the same position of the previous raster line. Now the raster is black, and we change the color again to for another line. We reached another time the border right edge,
Mhm.
and we change the color again for four time. One, two, three. No, three time.
Three
Three
times, three
for
times.
three line, not four. Not four. I
Okay, so let me remind the people, okay? So,
okay. Thank you. Please, please.
okay, so we just have the same routine that we have before, but he created three raster lines, as you can see. So he changed the color, he goes till the end, change the color to black, come back, change the color, okay? Again, as soon as he reaches the edge, he changes it to black again and does this three times. That's why we see a tick bar. The movement is using the same routine or same principle, same routine that we had in the previous example, okay? So all he did is he added, okay, and I'm just going to close this now. All he added is this, okay, three times. Let me highlight. I need to take control. Okay. Uh, all he did is he added this three times, right? Yeah.
Yes.
Yeah.
Right.
Okay. So the code is still the same. There's no change from example number 2, except that now instead of one line, he has three lines. Before he had a part of a line actually. Now he has three full lines on the screen, and one of these is just one line. Okay, where he is setting the border color. Thank you, Duncan. So basically, he's setting the border, then of course the raster line happens, and then he's setting the border again to black. So color, a number of no operations, so it comes, it forms a certain line, and then black again. And he does the same part three times. So actually, what you are seeing is, with all the respect to Emmanuel, if he permits me, is nothing special. It's just he's repeating what we had here in number 2.
Yes, I'm lazy.
Yeah, what we had in number 2. Okay, we had this routine. Okay, this is what he added. This routine here in number 2. He added this routine. But we had a routine, not a routine, we had a small line, which is this part, no? Which is where we are drawing our small little line. What he did is he made this line longer and he made it three times. That's what changed. So nothing nothing special. Andy, optimization in what sense? Because here it's not about optimization. Here is about being exact in the cycles. So you need. He could have written code here if he wanted, and
Yes,
does
a lot of the optimization can be
yeah.
made
So but
on this code,
yeah, but
but
it always needs to take 63 cycles. So basically, he could have written a routine that does what 15 or 17 no ops, what he has there, but still it has to take that amount of cycles. So in a way, it's optimization if you want to call it, instead of this repetition, because as he said, he's lazy. Well, you know, Emanuele, we always knew he was lazy. uh,
I was lazy because I was not to use cycles to reach the length.
but but the main thing is that the code should always take this amount. Okay, so maybe you are saving some memory, but in terms of cycles, you're always the same. Um,
Yes, yes, yes.
you always have to be
My,
the same. So that's all that he did, and because of
my
that,
goal was made.
mhm.
Sorry.
No, say it, say what you were going to say.
My goal was made more simple possibles.
Yes,
So the repetition of not for me was the simple things
yes. So
to make.
Emmanuel is doing the same thing that I do with the book on Saturday and Sunday. Sometimes, okay, I do not optimize, or even in the game on Friday, I do not optimize so that beginners can understand. It's better to see this repeated, okay, and it takes 63 cycles so that you understand that, than having a piece of code and it's hard for you to understand that it's trying to take 63 cycles. So it's more clear like that. Um, Remember, we are not trying to do demos that are strict by not just cycles but by memory and all that stuff. We are just trying to yeah, I understood you, Andy. Don't worry. I'm just explaining this in general to everyone. So I was not referring to what you said, um, uh, because it's good to point out that these examples are for teaching purposes, not for so that you understand the concept, not to say this is how you should do it. Of course, if you want to optimize, optimize. Um, that's the main thing. Um, the important thing, because you know what is the most important difficult thing is when you do not know or you do not know how to approach it. Once you know the way to do it, okay, then you can write the code. You cannot write code if you do not know how to approach it, and that's the difference. So this is why I'm saying learn the concept. And like anything else that I do, I always say learn the concept, because once you learn the concept, then optimization and all that stuff comes later. Okay, and you can go into the detail of that afterwards. Okay, Emanuele, have you finished explaining this code, or there is more to it?
Another little
Okay, okay, then
another
I give
little
you
thing.
control. Okay, it's all yours again.
Okay. After the last line, I will acknowledge the interrupter like the other one program. We make the same decrementing counter. The difference is that we change the direction and we change the color, avoiding the black one to avoid that we a totally black raster. This is the only one little trick, but little trick. uh, Anyway, the last part is the same. Is the same of the other.
Show where in highlight when you are highlight the code that you are talking about, Emanuele, because else it's difficult to understand what you are referring to. Sorry.
Sorry.
Indica, ok, con il mouse, ok?
Ok, sì,
Altrimenti
sorry.
non capiamo quale parte tu
Okay,
stai
okay,
parlando.
okay. Sorry. Here is the same code of before in the other program that decrement encounter to detect when the direction will change. But now I change the direction and I will change the color too with these two lines of code. And with this little end operation, I avoid I'm avoiding the totally black line because it will could be confused. It will not appear substantially. So I change the color, skipping the black one. This all. That's all. Sorry. Here I change the position for the next frame like before. Okay. And here I'm setting the new ERQ for the next frame at the new line that will be one line after on or one line before, depending on the direction that is actually used. Sorry,
Yeah, so basically
mi scappano le parole, cioè proprio
so basically it's the same.
I'm losing the word.
Yeah, so just to say what he said, so basically he will add or subtract add one or subtract one depending on the direction that the raster is moving, okay, whether it's going up or down basically, and then he will set the raster. In this case, the raster. This part is the same that we had before in the previous. So this part didn't change, Emanuele, right?
Yes, it's substantially the same.
Yes, it's still the same. It just explaining it again, but the real code is when he highlighted
Yes.
the part where he said that that's the part that was updated. So have you finished from here, or there is more?
No, I have finished this part.
Okay.
Okay. And only one thing. I think that could be a good idea for ones that won't start to understand the VIC programming to change some little things on this example to see how the VIC works.
So basically, I'm just going to repeat it in a maybe different way. As any
Okay.
other example that you get, to learn it better, okay, to learn how to manage the um, how to manage the VIC2 chip better, Emmanuel is suggesting, and I agree with him, because this is how you learn. Take the code and start changing things and see what happens, okay? Because this is how you will start understanding better what the code is trying to do. It is, how to say, actually, I can put it in simpler words, okay? In today's world, okay, we are used to watch a video, okay, and that's it. Basically, we know it, okay? Assembly doesn't work like that, okay? Assembly, you need patience, okay? You will watch a video and you will have to go and practice it, okay? You're not
Yes.
going to learn assembly just by watching videos. You will need to practice. Also, you only by watching a video, normally you only learn a small thing, because assembly, you cannot have a 1 hour video that will explain assembly. I think I saw some videos that say, okay, this is assembly in 60 minutes, sorry, 60 seconds, let alone minutes, and they exaggerate, but you cannot really learn. It's just they are fooling you, these type of videos. Assembly, you really need to um, dedicate time to it to learn it. Like anything else, you dedicate time and you practice, and that's how you learn. Now, if you want to learn the VIC to chip, how to program it, it's the same thing. You need to watch a video, get the source, and play with the source and change things. So you learn what you saw in the video, and you start getting it in your head, how things really work. I think on my Discord channel, this is the most, okay, thing, and I think Andy Manson can say this. If you go and read the messages on my Discord channel, this is what some people do not understand. They think they're going to learn assembly by watching the videos, but it doesn't work. You really need to go there and practice it. It's not like a high-level language of today, okay? The high-level languages of today are good, okay? They have their function, they have their use, but they are not assembly, and they do not have the power of assembly. They wish they had the power of assembly. And I'm referring to any high-level language that there is out there today. That is including C. They say the compiler is as fast as assembly, or that can compile as fast as assembly, but it cannot. Okay, it cannot. It can optimize, and it is good at optimizing because compilers became very good, but what they can optimize is a small little routine. They will not optimize, okay, a long routine that you might have. Actually, they might make it longer. So, yeah. Um, just to show you that you need really patience with assembler. Sorry, I always talk a lot about this, but it is such a big question on my Discord, that sometimes I do not know how to explain it better than, better than this. I wish there was another way of explaining assembly. You don't go and build a house without the foundations. You need the foundations to build a house. So it's the same thing. Anyway, so Emanuele, do you want to pass to the next example?
Why not?
Okay, so I'm going to show you the next example. Now, the next example, we will not finish it. We will start it and probably we will repeat it. The next example is quite interesting. We are going to move from stable raster lines to scrolling. And I'm going to explain a few things. I'm going to run it and then I'm going to explain a few things related to scrolling. Of course, scrolling is always on the Commodore 64 scrolling. Now, this is a typical screen. I mean, ignore that the characters are normal characters, okay? Emanuele is just demonstrating a scroll, okay? A scroll that is scrolling up. Now, what I want to say here is two things, okay? First one, notice that there is no color on the screen, okay? So this is the start of it, okay? The second part is that Emanuele, so this is the fundamental part, okay, what he's going to start explaining. Emanuele will expand on this because you tell me, hey, we will need color, okay? But to have color, you need to do certain things, and Emanuele is going to explain why these things needs to be done. There are various reasons. So if you want to score a screen and the color is always the same, that's perfect. You can see it happening here. When you want to add color, things change a bit. Okay?
A lot.
Sorry?
A lot, not a bit.
Well, just, it's beginners. Let's not make them
Oh, a bit.
let's not make them, discouraged. So, yeah. So please keep this in mind, that the scroll that you're seeing here is without color, just text moving on the screen. Okay? So, closing that, and I give control to Emanuele, unless I gave it. Yeah, you have control again, Emanuele.
Okay. First of all, my notes was not corrected by James, so all errors that you can see are mine. Is my guilty?
Yes, I didn't have time to check the English on this one, but I will have a look at it till next week, because this code will remain with us for quite some time. Also, I want to remind Emanuele to read his notes, his own notes. This is important now, that you read your own notes.
Okay.
Yeah.
Okay. In this program, I will try to explain how to make a simple hardware scroll. The hardware scroll is a technique used that C64 can make. So, how works hardware scroll? In the Commodore 64, we can scroll smoothly the entire screen without moving memory blocks, so in any direction. But we can scroll it for 7 pixels maximum. Even if it sounds like a limit, this limited scroll is enough to move smoothly the entire screen of any desired number of pixels. The trick is to move smoothly the screen on every frame of 1 pixel until we reached the 7th pixel. After that, we can only come back to scroll the screen of 0 pixel, but if we move all memory screen or the involved part in the scroll, because we can scroll only a part of the screen, of one char into the scroll direction before the next frame, we can create the smooth scroll illusion, superseded the hardware scroll limits between double Virgolette, come si dice virgolette? Non me lo ricordo.
In inverted commas.
Eh?
Yeah, in inverted commas. So just say the hardware scroll limit, and it's understood. Don't worry.
Okay. A little example to clarify all. In the first column, a little example is I tried to wrote here. In the first column of this table, sorry, this table. Okay.
Actually, can I stop you a second? You just remind me of something. Okay. So we are covering hardware scrolling. Okay.
Yes.
Okay. Now you know that retro programmers inside. Okay. They do. I'm going to say they. I'm just excluding myself. They do game jams. Okay. Now.
Yes. Yes.
Yeah.
Is not.
Now I'm going to say something. This lesson, okay, you will learn how to do hardware scroll, and this is very important because most of the challenges will involve something like this. Okay, so for example, we did the crazy climber before Pong. Okay. We did crazy climber before this. Hello, Sourcey. Yes, I know. I'm struggling, but we will manage. I'm pretty sure I will manage. The crazy climber involved hardware scrolling, okay? Because you are going up a building. So this.
But Trex 2?
Yeah, I'm going to say that. So we are doing hardware scrolling here, and it's vertical. We will continue with this series, okay? So this is part 1, okay, of scrolling, okay? So if you want to participate in Trex, okay, please note that we are going to cover also horizontal scrolling. So right now we are doing vertical and without color, and all the rest will come. And these are all things that you need to know, so that, I mean, these are basic things to be fair now, to be able to participate in our game jams, because most of the games, it's very rare that we have a game that is static. I mean, we try to have the game as static as possible, okay, so that it can be written in BASIC, but it's not always possible. Sometimes you need to mix BASIC with assembly or do it in assembly, because of the limitations of BASIC. So it's a good thing that you learn how to do hardware scrolling. This is one of the things that always, makes us decide whether a challenge, whether a game jam is good or not. Because if we see that it requires a lot of hardware scrolling or hardware things that you need to use by force assembly, then maybe it's not so good, because we would like people to use also BASIC. So that's why we keep it to a certain level. We don't go and try to make complex things in our game jam, because it's always related for people to learn. That's the aim of it. We want more people to code, and then of course they can become the best if they want to, but at least the foundation, we give the foundation. So Emanuele, please continue. Sorry for the interruption.
No, don't worry. It's a punctualization is a good point. I want to say another thing. In this example, I say we sorry. I try to explain the vertical scrolling, but in this example, there is all knowledge to make the horizontal scrolling, because I explain in some minutes.
Yeah.
Okay.
Yeah.
Okay. So I restart. A little example to clarify all is in this table. Okay, this one, but I lose again. In the first column, we have a frame counter. Okay. In the second column, we have the hardware scroll position. Are only numbers, but I hope that it was clear. It will be clear anyway. The hardware scroll position of the pixel in pixel, and in the third column we have the amount of the entire screen scrolled from the beginning, to create the illusion of the total smooth scroll. We how you can say, we have for the first seventh frame, we have an hardware scroll of 7th pixel, and the scroll, the charts, the memory on the charts are not moved, but that when we reach the eighth frame, we the only other value for the hardware scroll is 0 again, because we can move the entire scroll without using memory for 7 pixels. But before scrolling, reset this hardware scroll part of the register. In a moment I explain better this. We change all the screen in this moment. So we have the illusion um, to smooth to scroll the screen of 8 pixels. In fact, for the other 7 pixels, we can change anything on the screen, but only we only increment the hardware scrolling position of pixel. When we reach again the 8 pixels, we change again the scroll, we change again the entire screen, and so on.
I stop you there. I'm going to explain it.
Can you
Yes.
try to explain better?
So there is a hardware register, okay, which you can change the values from 0 to 7. Okay. This, when you are changing the value of this register, what you are really doing is shifting the screen upwards or downwards, okay, or horizontal or left or right. It depends which register you're talking
Yes.
about. Okay, so this is what happens. You're shifting, so the screen actually doesn't change. You are just so the screen memory, you know, the block of memory, it's still the same on the screen. It's just it shifts, so it gives the illusion that it is scrolling. Okay, when you reach 7, it resets itself to 0. Okay, if you let it, okay, without doing anything, okay, then that's when you see going up and boom, going down again. Okay, so that is today Defender. I mean, I don't know if he's here in the listening, but today Defender had the same thing on the Amiga. Okay, he was scrolling left and right, and he was reaching the register, and from, because the Amiga is 16-bit, okay, so it's from 0 to 15 instead of from 0 to 7. And when he was reaching 15, it was resetting to 0. And because of that, he was going like this, and it goes like that again to the left side. While what he has to do is not let it reach 0 and then start decrementing to have that effect of moving left and right. The same thing is for the Commodore 64, but instead from 0 to 15, it is from 0 to 7. When you reach 7, okay, before you put the hardware register to 0 again, okay, you move the screen, all the characters, one line up. So the top line gets erased, let's say that, okay, and what I mean by erased is copying what is in line 0, what is in line 1 into line 0, okay, and you continue doing this, okay, the shifting of characters from one line to another till you copy the whole screen. And of course, at the bottom, the new line comes in. Because you did this, when it resets to 0, okay, it starts again shifting the screen in the correct position, basically, shifting the screen, and you create this effect of smooth scrolling. I do not know if I explained it clearly, but I hope you understood me. If not, please comment or come to my Discord and ask me
Right,
questions. Yeah, ask me questions. I assume, Sorcy, you understood this, no? So, Emanuele, please
Okay.
continue.
Okay. The hard scroll counter is stored in 3 bits. This is the reason for the 7 pixel only. In 3 bits, you can count from 0 to 7. On 2 VIC registers, in 2 VIC register. Why 2 VIC register? Because one register is for vertical scroll and the other is for horizontal scroll. So in this case, I will try to explain the vertical scroll, but if you will apply the same things to the horizontal scroll register, you will reach the horizontal smooth scroll.
Okay, I'm going to say something to Emanuele. You are really lazy. And
Why?
I tell you why. I'm going to
I brought
impose, I'm
all
going,
these things with my hands.
I am going to impose to you, like what you have a vertical scroll, you should provide a vertical scroll. Sorry, a vertical scroll, you should provide a horizontal scroll. So that we have both. Okay, so my homework for Emanuele till next Tuesday is to provide a horizontal scroll. So we are in 501.
Okay. Sorry.
501, we will have 502, okay?
James,
Yeah,
when I said this,
yeah,
I want to say that I haven't horizontal scroll for the lessons, the future lessons. I said that if one of us follower is is in rush,
yeah,
is in hurry,
yeah.
can apply
Aha.
the things for the vertical scroll to the horizontal scroll.
Okay, so you
I'm
actually
lazy,
have.
but I'm not so lazy.
Oops, I made him angry. So you
No,
have,
don't worry. I'm not angry. I'm
yeah, I
joking.
know. So you have actually horizontal scroll.
Yes, I have some example.
Okay. So I retire what I said, and he is going to show us also horizontal scrolling, not just vertical scrolling. Now, to be fair, okay, Emanuele did these articles about 1 year and a half ago, something like that. Okay,
Mm,
and I have read them, and I have done them all. Okay, and but I
I'm
forgot.
rewriting it all.
Yeah, and actually I converted his articles into English when he was doing them, um, and I was checking also what he was doing. Uh, so, of course, because he's RPI and I'm RPI in a way. So he, I forgot that he did the horizontal scrolls, and actually there is one very good one I just remembered. So yeah. Anyway, it was in a way pulling his leg, no, because he always says he's lazy, so why not tell him that he's lazy? Can you
All
continue, please?
programmers are lazy.
Can you continue, please?
Okay. In this program, we will scroll smoothly the entire screen up, like you said before, with the rolling effect. So the first line of the screen will be copied in the last line of the screen when char scroll will be triggered. With the char scroll, I intend this moment or this moment. Okay, when the hardware register for the hardware scrolling have reached 7. Okay, I lose the line. Okay, we will use a raster interrupt to trigger it at the beginning of the lower border. So when our text is not involved by the raster lines. When our interrupt service routine will be called, we have a scroll of 1 pixel up for this example. So in this case, we have to count from 7 to 0 because the Y scroll is the is the name of the 3 bits that I said before. Because Y scroll indicates how many bits, how many pixels from the top will be shifted to the bottom. Uh, Shifted to the bottom. Okay. So we have to count from 7 to 0. When we reach the 0 in a frame, we have to scroll the entire screen up of 1 char at the next frame. So we have to change the entire screen from the bottom from the start of the bottom border uh, uh, before of the first raster line of the until the last raster line of the upper border. Okay. This operation is cycle consuming because changing the 1000 chars is a very time consuming operation. So it's important that it will be optimized to avoid glitches on the screen. Until now, I have illustrated how to move chart smoothly, but if we have many color, this is um, this is why James have noticed that my scroll is of one color. But if we have many color in the screen, we have to scroll day 2 when the scroll chart event occurs. In this program, we can't move the colors too, because the program uses all cycles to move the charts of the entire screen. In this case, full screen scroll. Other techniques will be used that will not be covered in this program. So, if substantially, if we want to change the color to uh, according to the smooth scroll, we have to use some techniques that uses the cycle in the mid in the other cycles when the border cycles only. To make this, we will use other techniques. To move colors and chart without problems, we have to scroll only some part of screen. Uh, in this way, so if we scroll half screen, if we want to scroll half screen, we can use more. We can have more cycle that we use to scroll the colors too. Columns and rows. Using hardware scrolling, the entire screen will be moved on of some pixel in a direction, but this shift creates a null of some pixel near the opposite border of the scroll direction. To hide this ugly effect, VIC can reduce the number of rows and columns, expanding the border and overlapping the holes, plural. This is enough to create the scroll illusion. If we don't, we didn't, if we will not reduce the borders, hiding these holes, we we will see the screen that dance up and down, left and right. Uh, would you explain better than me the what
So,
I said?
so you want me to explain this part? Let me take control first of all. So I'm
Yes.
going to highlight a part and tell me if this. You want me to explain this? Which part you want me to explain?
Yes, yes, yes,
Yeah, the rows and columns.
yes.
So this is the part where I said the screen. You need to scroll the whole screen up. So basically, what is in row 1 goes into row 0, and continue going this. Let me see. Let me read what he wrote actually. Using hardware scrolling, I was answering a question that I had while you were talking. Using hardware scrolling, the entire screen will be moved on some pixels in a direction, but this shift creates a hole on some pixels near the opposite border of the scroll direction. Yeah. So basically, if you're shifting up, okay, at the bottom there is, there is nothing. To hide this effect, okay, the VIC reduces the number of columns that you can see. So basically the screen becomes smaller. So if you're scrolling in the Y direction, I think it becomes 24, right? 24
right.
lines. And if you scrolling in the horizontal direction, it becomes 38. Okay?
Yes.
So when you are scrolling horizontal, you lose the first character and the on the left and the last character on the right.
Two columns.
Yeah, sorry, yeah, column. And when you are scrolling vertical or up or down, you lose the 3 and how is it 3 and 4 or 4 and 3? I forgot how it is.
Four lines upper and 4 lines down.
Yeah.
One character.
Yes. So for
one
character
rows. One rows only.
Yeah, one character in total, and you have 4 lines from top, 4 lines from the bottom. So that's why you need to make the screen a bit smaller to be able to hide this effect and you know, have the screen yeah, to do the scroll basically.
Yes. Okay. Can I continue?
Yeah. I mean, we can do another 10 minutes or so. So basically, let's decide when we stop. Let me see.
We can explain one register.
Yeah, you can. Basically, you can do this. Look, I'm highlighting it. You can do this.
Yes.
Okay?
Yes.
Okay, I give you control. And remember to highlight where you are reading or what you are saying.
Yes. Okay. First of all, I define the control register 1 constant. Okay. That is DO11 X. But is used in this example for the Y scroll. Okay. So I will try to explain the various the means of the is bits. So the 7th bits, we know yet the 7th bit is the bit number 8 of the raster counter. We have yet used in the past this bit. This bit is useful to track raster lines within DO12 when raster beam supersede line 2055. This bit is 1 if raster beam is beyond the line 2055. So the bit number 7 of DO11 is called HEM. HEM, extended color mode. This bit is used to use extended color mode clearly. BMM is the bit number 5. This is the bit for the bitmap mode is used to set in iris mode our Commodore 64. Okay, ACM and BMM are used within the bit MCM on DO16X that we will see the next time register to select a particular screen mode. So with 3 bits we have 8 combination, but not all these combinations are valid. Anyway, these bits are not covered by our example. This is only for your information. Then the 4th bit is called then. Display enable, used to switch on and off the text or the bitmap graphics. Normally it is set and it affected the two functions of the VIC, the bed lines and vertical border unit. Like the previous one, this bit is not covered by this example. Now, the bit 3 is the first bit that will be used in this example. If this bit R cell, if this bit is set, the upper and lower border are expanded, so the background lines really visible are 24, normally are 25. This bit is used in this example to hide the part of screen that will remain empty during the smooth vertical scroll. We can try to not set it during the example to see the effect. The next time we can try this. The bits 0, 1 and 2 are the three most important bit, even if are the first three bit on this register. Is important for us in this way. Sorry, I typo 0, 1, 2. Okay. These three bits are called Y scroll. The value obtained from these three bits indicates to the VIC how many pixels the graphics or the text will be shifted to the bottom. Normally, these three bits have the value of 3. Okay. We can stop here, I
Yeah.
think.
Yeah. So I'm going to explain this register. We have already
Yes, please.
seen bit 7, which is the bit that is used for having, is the 8th bit for the raster line. Okay, so it's because remember the raster line is not from 0 to 55, but it's from 0 to 318, I think. So you need the high bit. These bits we do not care. Okay, Emmanuel explained them, but for scrolling.
No, sorry. R cell is used
No, sorry,
by
no.
one.
These three we don't need. Sorry, I indicated. Yeah, these three we do not need. Emmanuel explained them, but for scrolling we do not need. One is extended color, the other one is high resolution, bitmap, and the other one is switching. Which one did I skip?
Display enable.
Display enable. Yeah.
Switching on and off
Yeah.
VIC2.
RSEL we need it because we need to make the screen smaller to be able to scroll, so this bit needs to be on. And then we have bits 0 to 2. That means we have a combination of 7 from 0 to 7. Okay, this is why this is what this register uses. Just going to mention something. If you are watching and you haven't hit the follow button for this channel, please do. I'm trying to reach 500 by the end of this month, and I don't think I'm going to reach them. But if you are following and if you are watching, please hit that follow button. I would really appreciate. So, Emanuele, why do you want to? I was going to tell you to explain this one too. Why you don't want to explain this one?
Okay. Sorry, my screen was not haven't scrolled.
Okay.
Yes, we can explain to the control register 2 is the counterpart of the control register 1 in this case for our purpose. DO16 even is used for horizontal smooth scroll. Even if this register is not used in this example will be useful to see its bits. In fact, with DO16, we can perform an horizontal hardware smooth scroll. Okay, bit 7 and 6 are not used at all. Bit 5 is used on the VIC version 6 in some version of VIX, but on the 6 in other version this bit used to stop the VIC. I don't know really what this means. I take this from the Christian Bauer manual that I cited before. This is the Bible of the VIC2 for me. In fact, I never used this bit. Okay, the MCM, I cited this before. MCM multicolor mode used with ACM and BMM on DO11X, the control register one, to set the display mode, like above I said. The first, the bit free is the counterpart of the bit free on the R cell, on the control register one. In fact, this bit is used to expand the right and the left border, reducing the visible columns to 38, normally are 14. The last but not least bits are the 2, 1, and 0. Another typo. The value obtained from these three bits, I'm lazy. I copied the other part. Indicates to the VIC how many pixels the graphics will be shifted to the left in this case, because we talk about horizontal scrolling. Normally, these three bits have value of 0. For the columns scroll, normally these bits are 0. For the vertical scroll, these bits are free. Why this? Why this is not 0? Because normally we have free lines upper used to hide the an alpha of char when this value is 000. In fact, if we reduce the number of lines, we reduce it of only one char, because reducing it of 2 chars, we will have too much little, only 23 rows. In this way, we can have 24 rows. That is better. Non so se mi hai capito cosa volevo dire.
No, I did not.
Allora, quello che volevo dire era che normalmente il VIC per l'X scroll è a 0, mentre per l'Y scroll è a 3 e non a 0. Questo secondo me, questa è una mia opinione personale, non ho effettivamente trovato riscontro di questa cosa. Secondo me perché così risparmiavano una riga riducendo lo schermo. Infatti lo riducono di una riga solo per le Y scroll and 2 columns for the horizontal scroll. Hai capito? Secondo te? Non so se vale la pena di dirlo questo.
Aspetta. This is the X scroll, no? So
Yes.
if you scroll from 0 to 7, the same like the other one, what are you trying to say here? I mean, what is the difference that you're trying to say between this register and this register? Also, I know why this bit is there. Okay, I will
When the Commodore 64 is just turned off, the value of Y scroll is free, and the value of X scroll is 0. Okay. The value of is free, but the value of Y scroll is free, but is at the beginning of the border is okay, because the border is
hold on.
non
This
so
register,
spiegarlo.
the X register goes from 0 to 7, no?
Yes.
Yeah.
This register 2, but normally is 3.
This register goes from 0 to 7 also. Right?
Yes. Right. Yes.
So what are you trying to indicate by saying normally 3 or 0? It depends what position you need.
Yes.
So they are the same, but one is for Y and the other one is for X. Right?
Sì, volevo solo far notare che il Y scroll non parte da 0 come l'X scroll, e volevo dire che secondo me è perché così riescono a risparmiare una riga quando si riduce lo schermo tutto là.
Okay. What Emanuele wanted to say is that the Y scroll doesn't really start from 0, okay? Because they wanted to save, I think, what they really scroll. So basic starts from 3. That's what you're saying, right?
Yes.
Okay. I'm just going to add something. This bit, okay, which Emanuel doesn't know what it is for. It has nothing to do with the Commodore 64. That is for the Commodore 128. That bit is to switch the VIC2 chip off, because remember the Commodore 128. Hello Dario. Because the Commodore 128 had another display. So when you are in ATCALIN mode, you do not need, it did not use the VIC2 chip. So you switch the VIC2 chip to be able and go to the other chip, to the other screen. They had different signals also. So that's why that bit was needed. However, I personally, okay, I just know this because I like the Commodore 128. I personally never touched it. I've never really done anything with the with this bit, but note that that's why it is on the 6566, because the 6566 is the chip installed, is the VIC chip installed on the Commodore 128, and
thank you, James.
And the difference between the 6566 and the other two is the 6566 is 48 pin, while the others are 40 pin, and the 8 pin difference is because of the Z80, because it needed to work with the Z80, and because of the other display that the Commodore 128 could support. So that's why there are those differences.
Okay.
However, I mean, I doubt you'll ever need to touch that bit. So, I mean, I've never seen it being touched, so I do not know. But the OS, the Commodore 128 Basic, I'm pretty sure it did it when you switched from graphic mode to another. And if you want to do a game in the other screen mode, that the ATCALM mode, probably you need to set this, but I
Okay.
doubt.
Now I understand
But I
why
doubt.
I don't know what the bit was.
Yeah. Anyway, that's, I think, basically it. Emanuele will explain these registers again. I'm going to take control, Emanuele. Emanuele will explain these registers again next week, but it's good that we mentioned them. And of course, he will cover the whole listing that we have. I have shown you, the scrolling that we have discussed. I want to mention it again. If you are following, please hit the follow button. Anyway, guys, thank you very much for following and for following the stream, and hope to see you next week. Thank you very much. Bye bye. Emanuele, please
Thank
say
you.
bye. Yeah,
Thank you all.
yeah. Bye bye. Bye.
Bye. Bye.